The views expressed on Skeptically Speaking do not necessarily reflect the opinions of the University of Alberta, the Students' Union, or CJSR.
Bring it on! The skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Shell gonna raise a little hell, metaphorically that is. 'Cause we're skeptically speaking.
Hello and welcome to Skeptically Speaking. I'm your host, Desiree Shell. Evidence-based people often discuss the media's misrepresentation of science. We've all seen examples of journalists sensationalizing a study's results or misinterpreting conclusions, from coverage of new fossils to Wi-Fi cancer scares. But sometimes, research is flawed before it even leaves the lab. Today we'll be talking about bad research. What are the mistakes scientists make? And what happens to the science when their research goes wrong? Let's start with a specific case of bad research. I'm here with David Dobbs. David writes on science, medicine, nature, and culture for the New York Times Magazine, The Atlantic, Slate, National Geographic, Wired, and Scientific American Mind. He's currently in London researching his book, The Orchid and the Dandelion. Welcome to Skeptically Speaking, David.
Thanks for having me.
So I've been following your work on the Marc Hauser situation. So first of all, tell us about Dr. Hauser.
Well, Dr. Hauser is a very prominent researcher of cognition and also morality. He has done all sorts of ingenious experiments and observations to investigate the evolutionary bases of things like social cognition, how we understand one another, and also morality, how we develop a sense of what is right and wrong. And he's done, as I said, brilliant work looking at how these things arose from our evolutionary past. He's looked at this in both humans and in non-human primates, monkeys in this case.
And his work's been cited in a number of other studies, correct?
His work has been cited widely, and it's gotten a lot of attention precisely because it is quite ambitious. And a few weeks ago, in July, an unfortunate thing happened for Dr. Hauser and for the discipline he's in. Harvard University, where he is a professor, released a statement that they had found him guilty of 8 counts in 8 different occasions of scientific misconduct. These are very serious and ugly words in the research world. Scientific misconduct sounds vague, but it's actually quite specific. It means that you have done one of 3 things that are considered to be very bad. One is plagiarism, which is using other people's work without attributing it. And the others are either falsifying or fabricating data. Falsifying means to sort of over-massage or over-filter or tweak some data so that it says what you want it to say. And fabrication of data is even worse. That's where you simply fabricate or make the data up. It's not completely clear which of these Hauser committed, but plagiarism is not on the plate. That's clear from various things. So it appears that he either fabricated or falsified evidence. It's quite a serious charge. It throws a lot of his work into doubt.
So what exactly is he charged with then? What did he do wrong?
Well, it's actually hard to know. This has to be inferred. Harvard has been working on this report. Its investigation has been going on for almost 3 years. The report was finished in January, but was not released until recently. And they are keeping the details of this quite close. At first, all they said was that there had been an investigation that Hauser had to retract one particular paper from a journal called Cognition, in which he looked at some behaviors of monkeys and concluded that they could detect certain differences in patterns of speech. Subsequently, they did release a statement that was more specific. They had found that he had, in at least 8 different instances, committed scientific misconduct. However, they aren't terribly specific about what exact studies are in question and what exactly he did wrong. There have been 2 things that have been very suggestive about what he did do wrong. One was some former students of his who have remained anonymous released to the Chronicle of Higher Education a memo that they had submitted, they said, as part of the report to Harvard, in which it sounded as if Hauser had either falsified or fabricated data when he observed a monkey listening to a tape. The details of those are rather arcane, but the main point is that he either saw something in the monkey's behavior that he really wanted to see, but that other observers did not see when they reviewed the same tapes, or he might have simply written down something he didn't see but wanted to see. We don't know which, but either way, it's a serious scientific problem. So that's one case where there's some evidence about what actually happened. It's anonymous, so it has to be taken with a grain of salt. The other was a conclusion written up by cognition editor Jerry Altman, who was privy to some details of Harvard's report because his journal had to retract one of Hauser's papers. This is a paper I mentioned a minute ago in which Hauser observed some monkeys listening to two different patterns of sound and concluded they could hear the difference in the patterns, and that this suggested that they possessed a sort of understanding of auditory patterns that is considered an underpinning for language. Now, Jerry Altman, the editor, concluded, after looking at everything and looking at the paper that he himself had published and then had to retract, that the only reasonable conclusion he could come up with was that Hauser had fabricated some of the data for that paper. And that is the most serious thing that has come out here, because fabrication of data is really kind of the cardinal sin in research.
Right.
Again, these are all partial stories, and it's still conceivable there is a somewhat more innocent explanation for some of this, but the evidence to date and what we know to date is pretty grim-looking.
Well, the pattern recognition experiment with monkeys that he did, this is definitely an experimental method, but it's also used with children's cognition.
Yes, this goes to a very interesting set of methods that have been developed first for use in children to basically be able to ask children, as it were, to tell you what they know or understand before they are capable of language. So these are pattern recognition things, and the way it works simply is you show the child two different things, or you can do this with a monkey. You show the child two different things, or let it hear two different things, and you try to decide whether the child or monkey can tell the difference by first exposing it to one stimulus several times until the child or the monkey gets bored of it and stops paying it any attention. Then you show it a different thing, so you show it a pattern of 6 dots instead of 4, or you play a tape of a different sound pattern than the first tape, and you see if the child or the monkey shows renewed signs of attention. So it suddenly looks again or longer at what you're showing it, or it looks up at the speaker because, lo and behold, here's something different. So it's a preferential looking or preferential listening paradigm that was developed to explore the cognition and knowledge of children. And Hauser brought some of this over to study monkeys because he wanted to study in monkeys what other researchers had studied and established pretty well in children. It's a very ingenious method that has been enormously productive in exploring infant and early child cognition. Hauser adapted it to monkeys, and in at least a couple of cases it appears that he took shortcuts to reach conclusions of which he may have already been convinced.
This particular methodology involves interpreting rather subjective data. And from what I've read, there were some rather more strict controls in other experiments than there were in Hauser's.
Yes, this can be a very tricky method. I visited one lab in which this was done a few years back when I wrote a profile in Scientific American Mind of the Harvard researcher Elizabeth Spelke, who researches infant cognition. And Spelke built on work of others before her. She wanted to figure out how much really young children, and these are infants starting at 3 months even, how much they understood about numbers, or as she calls it, numerosity. The idea is, can they tell the difference between, say, 4 and 5? Or can they tell the difference between 4 and 6, 4 and 8? At what point do they start to make distinctions between different quantities and scales of quantities? So she would show them, for instance, a card with an array of 4 dots on it and show it to them several times, and they would get bored pretty quickly of this and look around elsewhere. Then if she would show them a card with, say, 6 dots, and they would have the same reaction, it bored them. Then she might show them a 4 card again, and then a card with 8 dots. Now they would suddenly look up and find this interesting. And from that sort of experiment, she could see that they could distinguish between 4 and 8, or 8 and 16, and that their powers of distinction grew during their first year and onwards, of course. And she would use the same basic paradigm to see if they understood laws of motion, for instance, or permanence of an object, this sort of thing. And what her work and others doing similar work showed was that infants know a lot of stuff a lot earlier than we previously suspected. They understand, for instance, that people can lie at a much earlier age than we thought they understood that. And she also showed quite robustly that they did have a sort of rough grasp of quantity and some other physical laws at much earlier ages than previously suspected. So she and others have used these techniques to rewrite the book on early infant cognition.
Well, how did she go about avoiding the kind of bias that we see in Hauser's work?
Well, this is one thing that was so impressive in Spelke's lab. You have some obvious problems here. If you're showing the infant these cards and then you are scoring their reactions, it's very important for the person who is observing the videotape of the infant reacting to what the infant is looking at to not know what the infant is looking at. And Spelke solved this by setting up little rooms where the infants would take these tests. And the infant would be seated on the mother's lap. The mother would be blindfolded so that the mother's reaction couldn't somehow cue the infant. The camera was looking straight at the infant from just above a sort of little stage where the stimulus would be presented to the infant. So the cards would be shown or the little train would run along or whatever the experiment was. So this allowed Spelke to film the infant, and then whoever looked at the film did not know what the infant was looking at. So it effectively blinded the person who later coded these reactions to what the infant was seeing. And this is very important, that if you're scoring the infant's reaction, you not know what the infant is seeing. That's the sort of blinding that's very essential. And it appears that Hauser may have kind of gone around those blinding techniques or structures in some of his studies. One of the studies, for instance, the one that his students wrote about, suggests, and it's hard to tell from the memo, but it suggests that Hauser, when he scored this one monkey's reaction and determined that the monkey was looking at the speaker when it played the different sound, that he was aware of what the monkey was listening to and that he knew when the monkey was hearing the different pattern and would score it as having a reaction at that time. The students would look at the same film and not share Hauser's conclusion. They reported they saw no reaction, where Hauser reported that he saw a reaction. So Hauser had either skipped the blind and was being influenced by his impression of what the monkey was hearing, or possibly worse, if the student's account is accurate, he may have simply written in that the monkey reacted when not even he saw the monkey reacting. Again, we don't know what Hauser saw, but we know he made a report about the monkey's reaction that no one else who watched the tape shared. And that suggests that he had run around this blind that should be present in this experimental model. And as I said, when I toured Spelke's lab and watched some of the students scoring these tapes, there were very careful and consistent procedures in place to make sure this blind was maintained. And this is one of the many things that ensures the rigor of this sort of experiment and makes it so productive and reliable if the protocol is followed. But it's also something that makes these experiments really laborious and time-consuming to carry out, which may have been a problem for Hauser. I had a story in Slate last week in which I basically concluded that perhaps Hauser was simply a bit too impatient with the scientific process and with the very time-intensive, laborious methods that he had taken on and adapted for his monkey work.
So you mentioned pressure. Now, is that pressure that he would put on himself, or are there external pressures on scientists to produce?
Well, there are tremendous external pressures and internal pressures. Hauser is a professor of psychology at William James Hall at Harvard, and the building that contains his offices and Liz Spelke's offices, it's a building full of superstars. Steven Pinker is there, a whole mess of people there who have done just all kinds of wonderful work and gained great renown, fame, some of them, and in some cases quite a bit of wealth because it leads to best-selling books and that sort of thing. So this is a place where the rewards of great success and of successfully making ambitious scientific arguments are really evident to anyone in the building. I don't know if you want to call that pressure from outside, but it certainly can generate pressure from inside if you want to be that successful too. and if you are extremely ambitious. Now, this is one of the many, many ironies of this whole situation and of these scientific scandals, is when a person who's clearly very capable, as Hauser is, and very smart, as he is, overreaches. And not only overreaches, but apparently decides to take shortcuts that you just don't take. And where that happens, I don't know. This is a lot more complicated. This is the kind of thing that people who study morality talk about and study.
Right. So what are the repercussions then for him, but more important for the science?
Well, the repercussions for him are yet to be seen. We don't know everything that will someday be known. All the principles, he and Harvard are holding their cards very close to their chest, partly because federal funding agencies are investigating here, and they will make some determinations. So he might suffer anything from a pretty harsh rebuke and perhaps a lack of access to funding, all the way up to being squeezed out, forced out, or outright fired from his position. And it's just complete guesswork as to what will happen there. The field he's been working in, meanwhile, suffers too, in several ways. The people who have worked in his lab over the years and who have been co-authors on these papers, their reputations have been pretty much protected here because Harvard was finally good enough, after some people howling to have this happen, they were finally good enough to come out and say very explicitly that Dr. Hauser has taken sole responsibility for these 8 instances. Now, this effectively clears the names of others and obviously also effectively increases the scrutiny of his actions. But at the same time, their work on any papers that will be retracted is in some ways wasted. Other people have built upon this work and cited his papers. Those papers now need to be sort of reevaluated. You know, when you do scientific work like he's doing, and it's very ambitious, you're trying to expand the foundation of knowledge so that others can build upon it, among other things. Some of that foundation now is being removed, and other parts of it, people simply aren't going to be certain and as confident of it as they might be. So this is a real problem. In the meantime, there's always a danger that there'll be a pushback using this scandal, that people will kind of attack the fields that he's been in, so that there will be more skepticism about good work done in the evolutionary bases of behavior and cognition and morality or sense of ethics. And this is something a lot of other researchers who've done good work on this, like Liz Spelke or Franz de Waal, who has done work on chimps, and many others, that I would have to think they're worried about. As a matter of fact, Franz de Waal has expressed public concern about just that. So this is a big figure who fell really hard, and it sends a lot of waves out, and it will be a while before we know how it plays out. Months, years.
Thanks very much for being here, David.
My pleasure.
You can find more of David's writing at his new home on Wired. That's wired.com/wiredscience/neuronculture. And a few brief news items before we get to our feature interview. Some of you have sent me emails wondering if you could perhaps get your hands on a copy of the audio from the DragonCon panel I moderated, Raising Skeptical Geeks. That's the one featuring Adam Savage of TV's Mythbusters, Daniel Loxton of Junior Skeptic magazine, magician Jamie Ian Swiss, Laura Phillips, Laverne Angela Knight West, and Barbara Drescher, who will be on the line shortly to talk about bad research. The panel audio is available over at Podcast Beyond Belief, the lovely skeptical parenting podcast. If you'd like to take a listen, head to foundationbeyondbelief.org/FBB podcast. And if you're looking for video from DragonCon, visit podblack.com. Despite her hectic schedule, Kylie Sturgis managed to document some of the best bits, and along with her DC wrap-up for Curiouser and Curiouser at the Skeptical Inquirer, you can get a good sense of everything you missed. And now you have just under a year to plan for SkepTrack 2011. Speaking of skeptics, Virtual Drinking Skeptically, which is all the fun of a skeptics in the pub without the hassle of getting out of your pajamas, is hosting their 1-year anniversary extravaganza. In honor of the occasion, they're sponsoring a panel discussion on organizing critical thinking and science activism on the internet. Check out the lineup of panelists and see what else they have planned at virtualds.org. And I'd like to also quickly remind you that Dark Skies Bright Kids still needs your clickety-clicking. If everyone who's listening right now voted every day, they could be successful in their proposal to get multilingual astronomy books into Virginia third grade classrooms. All you have to do is go to refresheverything.com/darkskiesbrightkids and click vote. And then do that every day until September 30th. I've put it in my phone as a daily reminder. Just saying. And we'll be right back with more Skeptically Speaking after this.
Skeptically Speaking wants you to question everything. You can email your questions for next week's episode to live@skepticallyspeaking.com, or if you're on Twitter, we're at Skeptical Radio, or use our handy question submission box on the website at skepticallyspeaking.com. After the show, continue the conversation in the comments section of the website, or check out our Facebook group. You can also subscribe to the podcast on iTunes, and while you're there, why not add a review of the show? Skeptically Speaking is rebroadcast on a number of wonderful radio stations. Check the media page at skepticallyspeaking.com to see if we air near you. And now, back to the show.
Welcome back to Skeptically Speaking. I'm your host, Desiree Schell, and I'm here with Barbara Drescher. Barb is a scientist and lecturer at California State University, Northridge, and she researches perception, reasoning, and attention, and teaches research methodology. She's the founder of the Critical Thinking Education Group and founder of Woo Fighters, a campus-based critical thinking club. Welcome back to the show, Barb. So let's start out with David Dobbs' coverage of the Marc Hauser case. Now, he mentioned that Hauser was using the same experimental techniques for monkeys that are used for children. Is that unusual?
I think it's probably unusual simply because when you're dealing with humans and animals, there are established methods kind of for dealing with animals. But sometimes using a new method or an old method applied to a new area is helpful and solves some problems that you might have. The question that you want to answer really kind of dictates what sort of methodology you're going to use, because answering that question requires that you eliminate other possibilities. So whether or not it was the best method, I don't know if anyone can really answer that except him, but it wasn't a bad method. It wasn't, it just may have been a little slow for him.
So are there different methodologies then that are used in different fields?
There are. I mean, we use what works. Essentially, what we're trying to do in any scientific study is answer a question and then convince someone that our conclusions are good. So we want to draw conclusions. So essentially, a study is an argument, and you start off with premises, and those premises are everything that we know about that question so far. That usually is the findings of other studies, which is what makes ethical issues like the Marc Hauser case so difficult or so hard for his field. When David Dobbs was talking about how that calls into question all of the studies that follow or that based their research on what he did. That's what that's what he's talking about is the premises that you start with. If they're faulty, then the entire argument falls apart no matter how good your methodology is. But then the methodology itself has to actually be logical. We even use the same terms to describe methodology. We use the term validity. We have different types of validity that we look at. And if all of them are good and all of the methods lead to a conclusion, then we can say the conclusion is strong, if, of course, the premises are also strong.
Is this about ethics, or does using the wrong methodology potentially have other effects?
Well, I think there are two different issues there. I mean, ethics are an issue because if ethics are violated, then the conclusions are not trustable. But ethics can be violated in lots of different ways. The methodology, if you use, I don't know if there's a wrong methodology or if there's just a methodology that doesn't lead to the conclusions that you drew. So, for example, if you're studying something about, say, reading comprehension, well, let's say that you wanted to find out if highlighting helps reading comprehension. And then you use a methodology that is asking your participants to count the number of Fs that they read in a paragraph. And you highlight the Fs in one condition and you don't highlight them in the other condition. And of course, the people who are in the highlighted condition count more Fs than the people in the unhighlighted condition. You can't then draw the conclusion that they comprehended more because they weren't reading. They were just looking for Fs. So the methodology isn't bad if what you were asking for is, do they notice more Fs when they're highlighted? But if you're asking, do they read better or do they comprehend more, then it is the wrong methodology. So it's really a matter of, does your methodology allow you to draw the conclusion that you draw?
So then how does a study go from just research to bad research? Are there common mistakes that researchers make when they're designing their studies?
Yes, there are definitely common mistakes when designing. Young researchers, when they're first starting out, usually fail to consider a possibility, and so they don't have a good comparison. They may not have a proper control. For example, if you want to find out if something silly like singing opera before taking a test makes you a better test taker, and you ask half of your participants to sing opera before they take a test, and then you ask the other half simply to take a test, you've missed something, because just doing anything at all may explain the outcome. Whether there's a difference or not, it really doesn't matter. Your answer doesn't answer your question. What you need to do is have the control group do something during that amount of time. So if somebody spends an hour doing anything, that could be the explanation. It may have nothing to do with opera. So failure to have a proper control is a good one. Failing to do random assignment is another one, when your participants are they're assigned as they come in, or they're assigned to a condition that they want to be in, and then you draw a conclusion that your manipulation actually caused any differences in the outcome or in the measure. You can't do that if you didn't randomly assign them, because anything that is correlated with their choice, maybe some people want to take a class at 8 o'clock in the morning and some people would prefer to take one at noon. So if you're comparing 8 a.m. and noon, the people who choose those classes are different in some way that may have nothing to do with the method of teaching itself.
So there are actually far more variables involved than we would think.
Yes. Yeah, and we call those confounding variables. Whenever there's a variable, not a variable that could change the measure in any way, but a variable that actually correlates with the manipulation itself, with the thing that you're comparing. So with the treatment. It's actually a little easier to talk about treatments in terms of, say, pills. So if I was giving a pain medication, a placebo has to be identical to the medication itself, so that there can't be any difference. And they have to be handed out in the same way. They have to be taken the same way. One can't be taken with food and one without food, because anything that is systematically different between those two groups can cause any differences between them, including the gender of the researcher that hands them the pills.
Really?
Yeah, and these are common things that get missed, because there's so many tiny little details in research that you may not think, or you may think are innocuous, and they're not. Anything could make a difference. Now, that said, that doesn't mean that we should be criticizing every study that didn't use random assignment perfectly, or that couldn't use random assignment. Because if you don't have a reason to think that that factor would cause any differences, then it's probably okay, But we do have to temper the conclusions that we draw. We don't draw causal conclusions when we don't do random assignment.
So do you find that flawed studies usually, it's a control issue then?
Yes, it's usually a control issue. Not always, but usually. Sometimes it's the researcher really was looking for something and influenced it that way. And researchers can influence the outcomes in many ways that we don't even think about. But if they're a good researcher and they're a trained researcher, then they do what they can to remove themselves from the process and remove their biases from the process by putting in controls. But you can't always think of everything. Sometimes it's after the fact that you realize that there's another explanation. And that's why sometimes you will see in a study, you'll see a follow-up study that maybe could have been done the first time, but they didn't think of it until afterwards. And so they just want to find out, did this affect it? Let's find out.
You're talking about double blinding here to a certain extent.
Double blinding is one of those things that must be done when any expectation like placebo kind of effects, would affect the outcome. So it's one type of control. And it's a type of control in observational research, kind of like the Marc Hauser issue, that is absolutely necessary because we are completely biased observers. We see what we expect to see or want to see. And even if you know that and you try to control for it, sometimes you can overcompensate and actually see things the other way because you're trying very hard not to. You're second-guessing yourself too much. So if you're blind, you don't have to worry about that. If you don't know whether someone is in the treatment or control condition, then you don't even have to think about it. You just code what you see.
That's interesting because I once had a conversation with a friend about whether science was inherently neutral. And I, of course, was arguing for neutrality. And he was arguing that a researcher's opinion invariably makes its way into the research, and it therefore causes bias, obviously. So what are your thoughts on that?
That's interesting. I would say that it invariably makes its way into science, but it doesn't have to make its way into the research itself. You can design a very good study that doesn't allow you to affect the outcome. But if you're honest and you report everything, people can draw their own conclusions. That doesn't necessarily mean that you're not biased in the conclusions that you might draw from it. There was an interesting article today. There was a lawsuit filed for wrongful termination, I believe, and it was the person who filed the lawsuit actually accused someone of using a different statistical test because they didn't like the outcome. And that's a really tricky one. This was also in a pretty important trial. It was a cancer treatment trial. And the problem is that there are different statistical tests, and usually the study design dictates what test you use, and you know ahead of time what you're going to do, and you usually stick to it. That's at least the scientific method. But it's hard for scientists to not think, well, I didn't see it there, but you know what? The data don't really look quite normal, so maybe I should run this other test. Or maybe another test will give me more information, and then that other test may be less conservative than the original one, and suddenly you're seeing effects that you didn't see before. And it's easy to follow those, especially if they fit with what you think should happen. They fit with your view, your prediction of what would happen. Or if you just like them more, because because you want something to be true. That
because we're human,
so.
Right?
Yeah. So there are a lot of subjective decisions to make in research, but if you report everything that you did exactly as you did it, a reader can tell the difference between you drawing a conclusion that maybe you shouldn't be drawing, and you actually falsifying the data or changing something in some way.
And we're actually going to talk a bit more about that, but we have a caller.
Yes, we have Trevor on the line from Edmonton.
Go ahead, caller.
I was just wondering, we're talking about problems with these studies coming through, and, there's a lot of alternative health studies being done, and they end up getting published somehow, some way, but a lot of people look at them as flawed. So do you think it's the design of the studies, or is it misinterpretation of the data that causes people to look at these, I guess, with a skeptical eye, so to speak?
That's a good question, because we certainly don't want to discount a study outright simply because we don't like what it says. Usually when I look at studies that I've seen cited by alternative medicine, it's a bad design. A lot of these are what we call pre-test, post-test only. So they don't have a comparison group. It's sort of if you were doing a diet study, for example, and you simply had a group of people come into your study overweight, and they all took the diet. So you measure them, and then you put them on the diet, and then you measure them, say, a week later, and they've lost weight. Well, anything that happened between the time that they walked in and the time that they came in the second time could cause the weight loss, including being measured, being weighed, and being weighed publicly, and being expected to lose weight. And that's why we have treatment and control, right? A lot of the alternative medicine studies are these pre-test, post-test designs where they don't have comparisons, and those are fairly easy to spot. A layperson can read those studies and see that there's no comparison. But quite often what I will see when someone cites a study in an alternative medicine claim is that the study really had very little to do with what it is that they claim is going on. So it might be very far removed. So they may say something like, if you take this pill, or this herb, you'll be happier, okay? And the study they cite is some little component that happens to be present in the herb given to cells, that operate in some part of the body that has to do with fatigue or something like that. So it's very, very far removed from taking a pill and feeling better.
Audience, you're listening to Skeptically Speaking, and we're here with Barb Drescher, cognitive psychologist, and we're taking a look at bad research. Email us your questions at live@skepticallyspeaking.com or tweet us at Skeptical Radio. So let's go back to interpreting the results of a study. Mm-hmm. Now, we often see that the media finds causation where there's only correlation, but researchers are sometimes guilty of that as well.
That's true. And sometimes when you look up a study, you'll see causation. One thing that always gets me is when the title of a study has something like the word influence or effect in it, and they will be talking about gender affecting something or marital status affecting something. And of course, these are things that we cannot randomly assign. So we can't draw causal conclusions, at least not from one study. But more often, it's the media. And I think that's the lack of training. We naturally think causation when we hear correlation, especially if it seems to make sense to us. So we just kind of fall into that thought pattern. And I think that media reports usually say that. But sometimes researchers do too. And it's a sticky situation sometimes when you cannot do random assignment. Things like education, it's very difficult to randomly assign people to a classroom or to things like public works. If you have a public program and you want to help people get off welfare, for example, it's very difficult to randomly assign people to the treatment that you're hoping will work because there's the ethical issue of not treating the people that are not in the program. So you want to be able to say that something works. And if you didn't do random assignments, that's very difficult to do. But you can use converging evidence. It doesn't mean that we can never draw causal conclusions about anything. I don't know many people who would say that smoking doesn't cause cancer, for example, but we don't randomly assign people to smoke and not smoke because that would be really unethical. So we just draw from many, many different types of studies, and many mechanisms are studied, and all of that kind of converges to cause. And that's really how we get to cause when we're talking about things that can't be randomly assigned. But in a single study, when there's not a whole mountain of evidence, we usually do not say that A causes B unless we've done random assignment.
So if a study is flawed by design, or if there are ethical considerations, how does that get past peer review in the first place? I guess explain how peer review works, and then explain how it gets past it.
Well, peer review, it really does depend on the journal. But most peer review, what will happen is you'll send in a manuscript, and sometimes that's blind, where the authors and their affiliations are removed. And the editor sends that manuscript to people that are in the field that it's written for, who will read the manuscript, make notes, and sometimes they will say, I recommend that it be published without revision, which is very, very rare. Quite often it's you need to revise this or you need to revise that. And then sometimes they simply challenge it and say, well, how do you know it's not this? And you can do other experiments to kind of get to that point, or submit it to a different journal and hope they accept it or give up. And I think that there are certainly studies with flawed methodology that we still have something to learn from. Just because we can't draw the conclusion maybe that the researchers set out to study doesn't mean that we don't learn something very, very interesting from it. A good example of that, I know you're interested in the Stanford prison experiment.
I am.
Actually. That one's it's an interesting example because there's some ethical issues with it in terms of treating human subjects. We don't treat human subjects like that anymore. There are too many risks involved. And the prison that was created is nothing like a prison. It may look like one. It may even, feel like one to the people who are participating, but they're really just playing roles. They know that it's temporary. They know that they've been assigned to be there. The prisoners didn't do anything wrong to get there. I mean, they weren't there because they were arrested or because a court found them guilty of anything. So it's really nothing like a prison. So to draw conclusions from that study about how people behave in prisons is probably not a good idea. But we not only learned a lot about ethics from it, we also learned about how people will behave in roles where they're expected, where they've been told that you can be this way. And maybe they feel that they should, or that someone is watching them and expecting them to behave that way. I mean, there were cameras everywhere, and it wasn't as if any of the participants didn't know that. They may have forgotten, of course, but I think it really does tell us something about the power of the situation. These are not people who ever probably said that they would behave that way. And we make something called the fundamental attribution error quite often. And that is when someone behaves either good or bad, but it's usually when they make a mistake. We usually attribute those things to internal qualities, things like personality. Somebody who puts a quarter in the red bucket when Santa's ringing his bell, we'll call him generous. And we discount the situation, when in fact the situation is much, much more powerful than any of our personality traits or our personality factors, any of those things. We all like to think that we think everything through, and that we follow through on our attitudes, that our attitudes match our behavior. But the truth is that the situations usually drive a lot of our behavior.
But this is a case where we have very shoddy methodology. Mm-hmm. But you're saying the conclusions are not invalidated in this experiment.
I'm saying some conclusions are not invalidated. I think that you can't draw conclusions about what any specific person would do. I couldn't predict, for example, how I would behave if I were given the role of a guard, for example. But I think you can draw the conclusion that people don't always behave as expected. They don't always behave the way they think they will, and that the situation really is powerful. I think getting too specific about what we mean by situation is probably not a good thing. But we can certainly go into, you can now use that information as a hypothesis for another study and really get into issues of when does the situation matter more, and under what circumstances do people do this and that.
What I'm wondering about is under what circumstances are some conclusions of poorly designed studies considered valid, but then other studies, which are also considered invalid, something like Wakefield's autism research, now we would take, in effect, completely nothing from that research now, correct?
Yes. And I think it goes back to the word validity. Valid really just means do the conclusions logically follow from the premises. And that's why the conclusion that you're drawing really matters. Wakefield's his conclusions, even if he didn't falsify any of his data, which we now know is unlikely, he probably did falsify some of it, he drew conclusions that didn't match up with the premises. They didn't match up with the method. They went beyond what you could possibly say. And verbally, he said more than even what he wrote in the paper by implying that what he found was evidence of a correlation between the vaccine and autism. That is one of those issues where you really have to look at the premises and the logical form. If you could break it down to a basic syllogism, the classic syllogism, Socrates is a man and all men are mortal, therefore Socrates is mortal. There's a logical progression. It all fits together and it makes sense, and the conclusion logically follows from the premises. So when we use the word invalid, what we really mean is that you don't draw that conclusion from these premises if the premises are accurate. So if you're starting off with good premises and you have poor method, it depends on what the conclusion is that you're drawing, whether or not it does logically follow.
Audience, you're listening to Skeptically Speaking, and today we're talking about when science goes wrong. I'm here with Barb Drescher, cognitive psychologist, and she's taking your questions. Email us your questions at live@skepticallyspeaking.com or tweet us at Skeptical Radio. And we'll be right back with more after this.
On the next episode of Skeptically Speaking, we look at the stranger side of science with Marc Abrams, the editor of Annals of Improbable Research and the creator of the Ig Nobel Prize. He'll tell us why he believes that science that makes us laugh can also help make us think. And on Speaking Up, neurobiologist Dr. Richard Wassersug explains his research into the relative tastiness of Costa Rican tadpoles. That's next week on Skeptically Speaking, Friday night at 6 p.m. Mountain Time at skepticallyspeaking.com.
Welcome back to Skeptically Speaking. I'm your host, Desiree Schell, and I'm here with Barbara Drescher, cognitive psychologist, lecturer, and blogger, and we're discussing bad research. So, Barb, we have a bunch of questions. I believe we'll get to the first one.
Barbara, I love your blog. Could you explain what a meta-analysis is, and is it reliable? And that's from Keisha.
Well, first, thank you. A meta-analysis is when there are several studies. You have a question, for example, is co-sleeping a good choice? And you really want to know what the research as a whole says. So there are different ways to do a meta-analysis. Quite often what will happen is they will actually do a statistical meta-analysis, which is they'll take the numbers from several studies and actually do a specific type of statistical test that kind of aggregates them all and gives you a big picture. Sometimes that's not possible, and what they will do instead is look at really scrutinize the study. So you scrutinize the method, you scrutinize the generalizability. So who were the subjects and who are you trying to generalize to, and put it all together in a way that answers the question. So they can be very, very strong. They're really only as strong as the studies that were studied. But usually the person who is conducting that research, when they're scrutinizing it, they get a good idea of which are weak studies and which are strong studies and weight them accordingly or even eliminate the weak ones and come to a conclusion that's based on several different studies and answers. The statistical ones are particularly strong because they can actually use information about how many subjects were in each study. So a small study can contribute just as much as a large study, but the findings are weighted according to, how many participants were in there.
And a question from the chat room.
What would be the biggest mistake that people make when designing an experiment for the first time? And that's from Kylie Sturgis.
Oh, wow, that's a good question. I think the biggest mistake you could probably make is assuming that your observations are enough. I often have students who will want to know the answer to a question, and they think that just asking people will tell them the answer. So if you want to know if looking at a color changes your emotion, you can't just hold up the color, on a color chip or something and say, well, how does this make you feel? Because what happens is that the person is thinking about it, and they're thinking about that color. They have cultural associations with that color. They have personal experiences with that color, and those things affect their answer. And that's a response bias because their answer is filled with all of these cognitive things, and it really gets far away from that one question of how does it actually make you feel. Instead, you get how do you think it makes you feel. So you can't always just ask people the answer. You have to find ways to get at it without letting them think about it, because we're not as good as we'd like to think we are at knowing ourselves and knowing how we'll respond or how things work.
And another question from the website.
Is the placebo effect as present in psychological studies as it is in pharmaceutical studies? That's from Angela in Michigan.
Oh, wow. Probably more so, actually. It's a serious problem in psychology. And we have different names for different types of placebo effects. And there's actually something called compensatory rivalry, where let's say you have participants in a condition that you expect to do poorly compared to the other condition, and they find out, they'll actually try harder to prove you wrong. So we have lots of ways to control for that. But just the expectation of the researcher, going back to issues of double blindness, there's a great study, it's a classic now, where they went in and gave elementary school students an IQ test, and they didn't even open the test, so they didn't measure them. But they said they did. They told the teachers that a list that they gave them of randomly chosen students were going to be blossoming intellectually over the next year. And the teachers were not to do anything different or tell the children or their parents or anything. And yet, at the end of the year, when they gave them another test, or the students that were on that randomly chosen list, they improved more than the other children. So simply the expectations of the experimenter or somebody else involved can change everything. And that's a form of placebo in a sense, because it's the expectations.
And an email question.
Skeptical media makes an implicit promise that it will get to the bottom of weird claims to discover and share the scientific facts behind paranormal and fringe science mysteries. What quality control steps can skeptics take to help them keep that promise? And that's from Daniel Luxon in Vancouver.
Great question. This is a little near and dear to my heart. I think that understanding what you know and what you're able to speak to is important. We certainly need to do the work. We need to be looking for those answers. We need to look for alternative explanations, say, for what someone thinks is a UFO sighting, for example. So we need to be doing the research. But I think also we need to not derail ourselves by saying that we know something when we don't, or jumping to conclusions. I think that if we're going to talk about critical thinking and we're going to say that we must critically think, then it's really important that we recognize that we are just as human as the people that we are trying to convince to critically think. And so we're just as capable of being biased. And that's true for scientists as well. One of the reasons why people are accused of poor research ethics is often these probably were not malicious at all. It's just that the researcher really honestly believed that they knew what was going to happen, or they knew what was true. And their research had more to do with proving their theories than finding out the truth. And so they'll affect it in, little ways to kind of move it in that direction. We can't do that as skeptics either. We can't immediately assume that everything that someone says that has to do with ghosts or Bigfoot or something like that is wrong. We have to be objective. We have to walk the walk, not just talk the talk. And if we do that and do the work and do the investigation, then we will get those answers. But we can't get to those answers by thinking we know them already.
So I'm going to ask you the same question that I asked David. What are the pressures that lead scientists to making these mistakes or to even fabricate the data?
Wow, there's a lot. There's actually a lot. I mean, if you have a tenure track position at a university and you want to get tenure, the way to get that is to publish. That can mean publishing studies that are, when you read them, you think, why did they even do this? What was the point? What did it tell us? It can be that. It can be, there's a kind of a misnomer that if you don't find significance, if you don't, find some sort of an effect, then you can't publish. And that's not true. Null effects can be just as important as a finding. But yet, if you're looking for something and it should be there, and maybe your methodology is just not quite strong enough, or it takes a long time, patients can get the better of you. You have to produce in a certain amount of time. So you don't necessarily have the time to put in the kind of controls that are necessary. And I think David actually spoke to that a little bit. So there's that. There's publish or perish, and that really is true. Then there's also pride. You want to find something. Everybody wants an effect. In psychology, we all want this effect named after us. I wish I had found the Dunning-Kruger effect. Then it wouldn't be called Dunning-Kruger. So you really do want to find something. You want to contribute. And the way we contribute is by finding things that nobody else found. So we're driven toward that. It's very, very, very difficult to divorce yourself from that. And we shouldn't actually divorce ourselves from that. What we should be doing is making sure that our methods don't allow that passion into the process to affect the outcome. If we're careful, that doesn't happen. And then we just have to deal with disappointment. But of course, disappointment is one of the most difficult emotions to deal with.
And I will leave the last word to a listener.
In your opinion, can a researcher who is found guilty of scientific misconduct ever reestablish their reputation? I'm thinking of Wakefield. Could he ever be taken seriously now?
By scientists, no. I don't think so. I think that there's a certain amount of trust. Maybe if they were very young when it happened and they were supervised very, very closely afterward, people might be able to regain some trust there. But once trust is broken, we're all human. So that person has to now convince other people that they're not lying. That's not an easy thing to do. And even if there are all the controls in place, we still want to discount what they say because they lied to us. So there's an emotional component there too.
So again, this is a slightly depressing note we're leaving on the show. So this is not all inevitable, though. It's not all hopeless, correct?
Correct. I mean, science is. I really don't want to leave people thinking that science is bad, because it's not. It is a self-correcting process, and it's a very positive process. And when you think about it, when people are accused of bad science or bad ethics, it's almost always by other scientists. So that's good evidence that the scientific process is good. And because it is a community process, because it's not an individual thing, it's shared knowledge, we can maintain its integrity. It may be slow because of that, but that ensures its accuracy, and that's what science values. It values accuracy over immediacy. That makes us all impatient, but it also makes good science really, really, really good.
And on that note, we're out of time. Barb, as always, a pleasure to have you on the show.
Pleasure to be here.
And Barb's blog can be found at icbseverywhere.com, and we, as always, are at skepticallyspeaking.com. From there, you can listen to our past episodes, join our Facebook group, follow us on Twitter, or subscribe to the show in iTunes. Thanks for listening, and we'll see you next week on Skeptically Speaking.
Hello, this is Richard Saunders from Sydney, Australia, the host of The Skeptic Zone, a science and critical thinking podcast. When I was younger, I was one of those kids who wanted to know how it worked, what's inside, how does it tick, how does it move, why does it do the things it does. And over the years growing up, I've discovered that the best way to find out is through science. I mean, a lot of people have done the work already for you, but I must say there's nothing more magical than discovering things for yourself. Sometimes I pinch myself. I think, my goodness me, I'm living in the future. When I was younger, the planets were yet to be discovered the way we know them now. We didn't know about extrasolar planets. We do now. We've got photographs from Mars. That's so exciting. I mean, I can sit at my computer at home and look at the very latest stereo pictures from another planet. This is just a dream for thousands of people over thousands of years, but we're living it now. We can do it from the comfort of our own home, and it's science that brings us there. And it's science that helps us look at what intrigues me, which is real mysteries still to be solved. I'm out there solving them, and it's thanks to science.
Bring it on, the skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Shell, gonna raise a little hell, break the spell of Pavlov's bells. Cause we're skeptically speaking, on mind reading tarot cards and witches, psychics, and their spoon-bending mind tricks. All the humbug, flim-flam, frauds and shams, the charlatan woo. I don't think you understand, it's the hocus-pocus, out-of-focus locus, eroding the brain, making gains on the hopeless. Let the crystal ball fall, smash on the floor, leave the pieces alone, we don't need them anymore. Just a microscope, telescope, magnifier, reading in between the lines of these lies. Bring it on, the skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Shell, gonna raise a little hell, metaphorically that is, cause we're skeptically speaking.
Skeptically Speaking is recorded live at CJSR in Edmonton, Alberta, Canada. Michael Harrison manages our electronic communications. The soundboard is run by Ryan Bromsgrove. Lisa Skovanek is our assistant studio technician. Post-production editing and additional research by K.O. Myers. Our theme song is written and recorded by AOK, and I'm your host, Desiree Schell.